So here in this question, the surface of balloon can become charged by rubbing it against clothing. The charge on surface of the balloon can be assumed to act as if it was concentrated at the balloon center. Okay. The two balloons are suspended by cotton threads so that they just touch each other as shown in the diagram 1. Okay. So that means both are charged with a negative charges. Obviously, what happens is, they will repel each other because electrostatic force will be there. The two balloons are then given an equal negative charge and repel as shown in the diagram. The dot represents the center of the balloon. So initially it was not charged. So the distance between the centers is 0.21. Now what happens is, once it gets repulsion, mutual repulsion, so what happens, it is shifted again, correct? So what happened is, you can represent the same figure. I would like to represent a schematic representation of the same. Like, this is one balloon. Initially the two balloons was just in this position. Now what happened, this got a repulsion. So what happens, this will be repelled, and equally it repelled. So that means it makes an angle theta, correct? So initially the distance between them is 0.21. Any doubt? Now the new distance is what? The total distance now after repulsion, what is the new distance? That is 0.47. So that means ultimately it shifted the difference between 0.41 and 0.21. So that is a distance shifted, correct? So that means if I'm taking the difference between, because the difference between 0.41 and 0.21 is 0.26, correct? So that is the total distance shifted. So we know that this is a symmetrical figure. So if 0.26 is the total shift, then the individual shift will be 0.26 by 2. That means 0.13. So that means this is shifted 0.13 and this is also shifted 0.13, such that 0.13 plus 0.21 plus 0.13 altogether 0.47. Any confusions? Hope you got it. Now we know that the distance of this, this thread is 1.22. So that means even this distance is also 1.22. So I think we can develop what? So this we can find this angle theta, correct? So we can find this shifting angle theta by considering this as a right angled triangle, correct? So I'm just considering this a right angled triangle such that this distance is 1.22. This is the angle of shift and this is 0.13, correct? So this will help us to find what is the angle. So for example, if you are taking sine theta is opposite side by hypotenuse 1.22. Therefore if you are finding the inverse, you will get 6.12 degree. So this angle is 6.12 degree. So we got this angle shift after this beautiful repulsion. Now we can make a free body diagram. So I would like to draw a free body diagram. So this is the free body diagram. So I'm just considering only one balloon. So this is the shift happened for each balloon. So we know that there is a repulsive force. We don't know what is that repulsive force, that that is purely acting in the horizontal direction. And since it is hanging on a cotton thread, definitely a tension is there. And if this angle is theta, definitely this angle is also theta. Now we know that this balloon has a mass. The mass is what? Mg. So could you please help me to find the resolved component of this tension? So if I'm resolving this into two components, here this is what? T, the component is T sine theta component is balancing the repulsive force, and T cos theta component is balancing the weight. So you can easily figure out, because this entire system is in equilibrium. Therefore they're asking to find what is the repulsive force, correct? So Fr is equal to T sine theta. We already calculated the what is the value of theta as 6.12 degree, correct? Now, similarly, we can, this is actually what according to the horizontal component for total force on the x direction is equal to 0. Similarly, total force on y direction is 0. So that means mg is balanced by the t cos theta component. Therefore, from this, we can easily find what is tension. Tension is mg divided by cos of theta. That means mass is given according to this question. What is the value of the mass? 1.1 grams. So 1.1 into 10 to the power of minus 3 into 9.81, because the acceleration due to gravity is 9.81 divided by cos of 6.12, correct? So this will help us to find what is the value of the tension. So take your calculator and find what is the value of the tension. So if you are substituting this value, we will get 0.01085, that much of Newton. How this will help us to find, the repulsive force, because the value of repulsive force is T, that is 0.01085 into sine 6.12, because angle we already know. So you just multiply it with the sine 6.12, and that will help us to find the value as 0.01157 Newton. So that is approximately 1 into 10 raised to minus 3 Newton. And that's what they're asking us to solve. Clear? So here they're asking, show that the force of repulsion between the balloon in the diagram 2 is about 1 into 10 raised to minus 3 Newton. So we calculated it. That's it.